Today's on a Saturday, and my friend was doing a CTF called LACTF, I guess that's the name, and he called me in for some help, and I was able to do a reversing challenge called final simulator, and that's what I'm going to look at. This description, to be honest, is not really helpful, so we can like copy the link here to the binary, then use wget to get it. From there we can give it executable bits. We can use file to get the file type. So we are told it's not stripped and it's dynamically linked, so we can basically check its link like that, and it's a 64-bit least significant byte executable, so that's awesome. The next thing we are going to try to do is just run it. So this is dynamic analysis, and you are told what is sin x over n, so I'll just give it 23, and we are told wrong, you failed. So I'm just going to use another program called ltrace. So this will trace the library functions. So for example, if it's using something like string compare, we will be able to see what it's comparing that with. So I'll just enter 3, and we see that it's using strc spn to get the count of our input, and we get it's 1. So basically it's also using string compare to compare our input with 6. So basically 6 is the right option. So if we had entered 6, this would equate to true. So we give it 6, and it continues to ask us what's the prettiest number. So I'll just give it like the lit number, I guess, and you're told wrong, you failed. So that's interesting, because now we don't have a way to check how that lit number is compared. So basically the next thing I would think of is just use radare, and then I'm just going to open it in debug mode, I guess. So basically this likes it like that, and then we can give it AAA for analyzing. Then we can list all functions, then we can just seek to main and print the disassembly. So what you will notice is that this was how it was comparing the 6. So it was passing this to RSI, so this is the second argument. Then our input was being passed to RDI. So basically we have the first argument and the second argument being passed to the string compare function. The next thing is that it's asking us for the prettiest number, and then using a flash to flash the buffer. So that is just creating the buffer, and then there is 88 being added to EAX. So I'm guessing EAX is our input, because basically the return value from a function is always stored in the RAX. So in this case it's being stored in the 32-bit lower part of the register called EAX, and then after adding 88 it's being multiplied by hex2a, and then that value is compared to this value. So without further ado, I think we just need something like this, and then I'll just launch my Python 3 interactive console. Then we can do something like can we divide that with hex 2a, I guess, and we get this. Then from there they were adding 88, so basically we can subtract 88 from here. So we subtract 88 from there, and we get the number is 1337. So yeah, it's lit 2 times. So that's awesome. Basically the next thing we can try to do is navigate to where we were, and then we can see finals. Awesome. So we can try again ltrace, and then this guy here, then we can enter 6 and then the lit number, and we can see we have passed that. So we are being asked what's the integral of 1 over carbon decarbon. I don't know. So after we pass the thing, we get the third question, which is asking what's the integral of whatever. We get that it's getting the character by character, and then the buffer is 256. You can see it from the ESI, so that's the second argument. And then we have RDI being the RAX, so it's being stored in that buffer, that is var 110h. The next thing we can see is so this is the pointer, then the size, that is 256, and then the file stream. So the third argument of course will be stored in so that is RDI, RSI, then RDX, so that is standard in, which is 0. The next thing we are trying to do, we are loading so that's just the \n to signify that it's the end of the string. Then you are getting the count of that string, and then we are jumping somewhere. So where are we jumping? We're jumping here, testing L, then we are jumping not equal to hex D3 B3. So I bet this is up here, but yeah, so D3 B3 is somewhere here. So basically you are like jumping up here. So this is like some kind of a for loop. I really don't care. So the next thing you are trying to do is I really don't know. Actually, this is really boring. Can you try something like ghidra? Something that will give us a pretty nice view of how this is working. Then you can come here and import the file. So you just press I, and then you get the final simulator. Then you can like import it like that. So I've already imported it, it's here, so I'll just launch it, then take it to, so basically we want to analyze it true, and then I'll just take it to my third pane. So we saw it's not stripped, so you can search for main here, and let's see. So the first question was quite easy, so that was 6. Then we did the calculation here, and we are supposed to enter lit 2 times. Then it's coming here to get our local, so this is the buffer. So basically you can rename that to buffer. Then from there you get the count, so this is just the length. You can check that in the man pages for sure. So it's something like, I guess, man strc ps, what was that again? Okay, CSPN, okay. And then it's in the third category of the man pages, so those are the library functions. So yeah, this function calculates the length in bytes of the initial segment of s. Yeah, so that's it. Okay, let's go back here. So basically what this is doing, it's calculating the length before we get to the new line. Then from there it's terminating the string with a null byte. Then this should just be an iterator, a counter. So we are counting until you get to the new to the null byte, and we are just doing some calculations here. So okay, I wanted that to be in decimal, so 253. So basically it's like you are tracing the whole buffer, which is 264, and then we are just printing 10 there, and then you are comparing the buffer with this one. So that is really interesting. So maybe we can call this a result, I guess. Interesting. So what is this thing? So that's a hard-coded variable. Interesting. And then we can see okay, so this is from the like the 0 index to 19. So basically I guess this is the value of the encrypted thing. So we need to kind of find a way to reverse that one. So we're just going to the temporary folder, challenges, and then come here and we can create a new file called data. Then from there we need to delete this. So the way you go to the last line is just like shift and then the $sign, so that will take you to the last line. Okay, so that's awesome. Then you can delete this one. So this is a pretty odd way of deleting things. You can just hit DD 2 times, so that will delete it. But I'm lazy, and I'm really lazy again. So yeah, so this is data. So we can cut data, and this looks, we need just this part. So basically this part, because this is the address and then this is just gibberish, and then these are the indexes. That is the fourth field. So basically maybe we can just use something like awk, and then in the main part of awk, that is the main body, because awk has like 3 parts. So there is the beginning, the end, and the body, the main body. So in the main body we are just going to print the second field like that, and then is that. So then we can give it the file, I guess. Okay, so I guess this should be like that. And yeah, so we have that. Then we can use translate to just get rid of the new lines, and so we are like translating that to something like this. So basically, let's just think about it for a minute. Basically, I think so this should be to temporary directory. So we can create a new script.py. The next thing we can try to do is just get this thing here. So this operation here, then you can get that as a comment, to be honest. So something like that. And look at me, I just forgot how we comment it in Python. So basically something like that would work. So checking this, we want this to be in a list format. So basically I think we can do something like, we can pipe this to translate again and get rid of the new values like that. And yeah, so we have that. So this doesn't work as well. So this is interesting, really interesting. Yeah, now it works, but that was really interesting, to be honest. So we need this here, and we need it to be our data. So data equals to, so we are just creating a new list, yeah, something like this. And of course Z missed things somewhere, I guess it's the first character there, yeah. And so we have all that. Now let's try to understand what is happening here. So our input string is being looped through, and for every character it's performing this operation. So this is really nice. What I'll do, I'll remember, when you see something like modulus, you can't undo that calculation. Any calculation, like there is an infinite number of values that can fit into something that is done after modulus. So maybe like 25 modulus 5, that is 0. There is an infinite number of values that can, when they are done its modulus on, will get 0. So basically you cannot undo that. So what I was thinking is just trying a few value of numbers, like maybe for I in data. So we loop through our data, then we can do something like for I in a range, and we give it something like 1000. Then we get the number. So the number is I, you multiply by 17. Then from there you get the modulus. So this will be modulus with 253. So, and then if this number equals to the data, actually I'll do something like, let me think about it. So this will be 0e. So let me get the integer. To compare, we need the integer of I, and it's from 16, so that is from hexadecimal. So if number equals to CMP, then we can print something like, so I'll just include some format string there, and then we can do something like this. So basically, of course, we would need to know the I. Okay, basically I messed up here. So basically we can do something like J, I guess, just to differentiate the function. So J, and then okay, so this will be like J, I guess. So J equals to J, the num equals to num, I guess. So something like that. I'm not sure if that will work, but basically let's try that out. We give this executable bits, and then we try to run it. Okay, so for comparison we need, of course, 2 of them. Yeah, and we get this. So this is for the 0, and what we can see right now is something that is not really nicely outputted. So basically what I'll do here is I'll also print I'll also print something like CMP, I guess, or J. Actually I'll just print J. Yeah, and now this is nice. So basically we'll just redirect this to data. Basically not sure, let's list, and so I'll just redirect this to the file, something like that. So now we can vim file. Okay, and what I'll try to do here is select the first things in a row, and yeah, something like that. We'll just use the first numbers, I guess, because I said there is a like infinite number of values that can fit into after a modulus equation. Yeah, and now we have a well filtered number, and so basically what you can try to do is just mark that as that one, and now we need the values also in a list format. So basically I think what I can try to do from here is try to format this on the terminal, so we can cut that and we can get rid of anything data, and we can get rid of anything double quotes, I guess. Then the next thing we can try to do is grep for I guess, and after we grep I, the next thing we can try to do is grep for equals, and since we have that, now we can pipe this to awk, and on the main part of awk we can print, I think, 11th field. And yeah, so that's what we need. So basically I'll just pipe this to another translate, and so we will get rid of that to some spaces, I guess, and then from there we can pipe this to sed, and from here we just need to say we are substituting the space with something like this. Okay, that didn't work. Okay, we need to specify that we are doing that globally, and yeah, so this is what we need. So we can let's just leave that there. I guess we can just like append this to our solve.py. Yeah, then we can go into solve.py and check that. So now we have our data there, and we can just specify that we need that one there, and basically we can close that one there. So what I'll try to do, since we see that we are entering as a string, I'll try to convert this from their decimal to their ASCII character equivalent. So how I'll do that is something like for I in data. I think you can also try this in a one-liner, something like flag equals to, or basically I just say the data1 equals to a chr, I guess, chr of I, so that is the character function, and then for I in data, so something like that, and then you can just print you join the thing so that it won't be like outputted as an array, and then so we are just joining the data1. So let's see, now we can execute our solve.py. So basically just giving it the executable bits, then executing it. The funny thing is that object cannot be interpreted as integer, so that is awesome too. Maybe we can try something like, we can try changing it to an integer. So basically you just say, actually yeah, that will work, and you can see, yeah, it's a log cabin. So basically I think this is what they were like now expecting, and I'll just come back here and give it's a cabin, and it says that it cannot read flag.txt. So basically I'll just get my echo flag.txt there, and then we try doing it again. So this is final simulator, then this was supposed to be 6, then the lit number 2 times, and then that one, and we see that we get fake flag for testing. And now that was just how we should have done it. So you can come here to the netcat thing, and just this is how we just connect to it, and then we give it 6, then the lit number 2 times, and then okay, so that's where we failed. Okay, so I'll just copy this again, then we give it 6 again, and then the lit number 2 times, and then we give it that one, and we get the flag. So see you next time.